Hello guys and welcome back to the channel. This is Surya from SVC. Today we're going to be talking about working of a solar cell. Now, talking about a solar cell, we need to first discuss what is a solar cell. As you can see here, a solar cell is also known as a photovoltaic cell or a PV cell. It is defined as an electrical device which that has the capability to convert light energy into electrical energy through the photovoltaic effect. A solar cell is basically a PN junction diode. Solar cells are a form of photoelectric cells defined as a device whose electrical characteristics such as current, voltage, resistance vary when exposed to light. So when you expose these photovoltaic cells or solar cells to light, the current, the voltage and the resistance will vary from when it's not exposed to the light. As you can see here, look at this. Looking at the image, we can see this is a solar cell where sunlight will come in and it hits the solar cell. Look at this. The sunlight hits the solar cell and then that solar energy or light energy is converted into the electrical energy. To continue, individual solar cells can be combined to form modules commonly known as solar panels. The common single junction silicon solar cell can produce a maximum open circuit voltage of approximately 0.5 to 0.6 volts. By itself, that isn't much, but remember, these solar cells are tiny when combined into a large solar panel. Considerable amounts of renewable energy can be generated. Imagine a huge field of solar cells combined and put as solar panels. Imagine how much electricity it can generate when a single solar cell can generate up to 0.5 to 0.6 volts. Imagine thousands of these solar cells combined. Imagine how much renewable energy they can generate. Now, we'll see the construction of a solar cell. A solar cell is basically a junction diode, although its construction is a little bit different from conventional PN junction diodes. A very thin layer of P-type semiconductor is grown on a relatively thicker N-type semiconductor. We then apply a few finer electrodes on top of the P-type semiconductor layer. As you can see in the diagram, I'll let you study the diagram. I won't interrupt much, but I'll just explain the basic layout of it. Here we have a switch that can go on and off, and this is a hole. The thing here is hole. This is electron hole recombination. Here we have photon hits the solar panel. This is the front electrical contact. This is the N type, the depletion zone P type, and then back electrical contact. Here photon absorbed in the depletion zone, electron hole creation. Here the photon is absorbed in the depletion zone over here, and then electron hole will be created which allows the electron flow through here and then into the switch. This completes the circuit. This is the basic construction of a solar cell. These electrodes do not obstruct light to reach the thin P layer. Just below the P-type layer, there is a PN junction. We also provide a current collecting electrode at the bottom of the N-type layer. We then encapsulate the entire assembly by thin glass to protect the solar cell from any kind of mechanical shock. Now we'll see the working principle of a solar cell. When light reaches the PN junction, the light photons can easily enter in the junction through very thin P-type layer. As the p-type layer is very thin, the sunlight can easily enter into the junction through the p-type layer. The light energy in the form of photons supplies sufficient energy to the junction to create a number of electron-hole pairs. The incident light breaks the thermal equilibrium condition of the junction. The free electron in the depletion region can quickly come to the n-type side of the junction, thus creating a hole. Now we'll see the VI characteristics of a photovoltaic cell. Now here in the y-axis we see current in amps. In the x-axis we see photovolts with PV volts, which means the voltage of the circuit. This is a maximum power point that can be generated in a photovoltaic cell. This is the MPP, maximum power point. This is the short circuit current, and this is open circuit voltage over here. This is the VI characteristics of a photovoltaic cell. in the form of a graph. And then moving on, we see materials used in a solar cell. The materials which are used for this purpose must have a band gap close to 1.5 electron volts. Commonly used materials are silicon, gallium arsenide, cadmium telluride, and then copper indium selenide. These are the general materials used in making of solar cell. Moving on next, criteria for the materials to be used in a solar cell. The materials must have a band gap of above 1 electron volts to 1.8 electron volts, which is basic in the range of 1.5 electron volts as an average. It must have high optical absorption. It must have high electrical conductivity. The raw material must be available in abundance. The cost of the material must be low. Well, it should be comparatively low when considering the large scale of production of solar cells, as it is a primary source of renewable energy. Moving on, we'll see advantages of solar cell. The advantages of solar cell are fairly obvious, as it has no pollution associated with it. As no pollution is not necessarily true, because there will be some sort of pollution during the production of the solar cells, but when compared to the other energy resources, it is insignificantly low. As you can see, after the production, there will be like almost zero pollution associated with it. And the advantages are it will last for a long time, and there is no maintenance cost for it unless we have tiny repairs because of some external factors. Now we'll see the disadvantages of solar cell. It has high cost of installation, it has low efficiency. During a cloudy day, the energy cannot be produced, and also at night time we will not get any solar energy. With this, we'll be ending the video. Yours sincerely, Suryam. Thank you.